Welcome to Valenzuela Live Mathematics 6. It's nice to see you again, grade 6 pupils. It's me, Teacher Marlene Carduce from Constantino Elementary School, your teacher for today. So we are now in the 9th week, still under the first quarter of our math discussion. So today, I will discuss to you on how to differentiate terminating from repeating non-terminating decimal quotients, and how to solve word problems involving division of decimal numbers. So let's start our discussion with the problem. So Mrs. Santos and Mrs. Reyes went to the market and they want to buy 1/4 kilogram of pork and 1/3 kilogram of chicken respectively. When they are in the meat shop, they place it in a digital weighing scale to check if they get the right weight of meat. So these are the readings for the two meat. For Mrs. Santos, her 1/4 kilogram of pork read as 0.25 or 2500 kilogram, while for Mrs. Reyes, her 1/3 kilogram of chicken reads 0.333 kilogram. Now, did Mrs. Santos and Mrs. Reyes get the right weight of meat? If yes, put a heart reaction. If not, put a like reaction. So let us check if they get the right weight of meat. So as you observe in the problem, the given numbers are fractions and decimals. And if we're going to recall the relationship between decimals and fractions, fractions can be expressed in decimals if we divide the numerator by the denominator. So numerator will be the dividend and the denominator will be the divisor. So let's first check the weight of Mrs. Santos' pork, wherein 1 is a dividend and 4 will be the divisor. So 1 as a dividend will be written inside the division symbol, and 4 as our divisor will be written outside the division symbol. Then we can now start dividing the numbers. So 1 divided by 4 is 0. Since the dividend is smaller than the divisor, we will put a decimal point after 1 and also above it where the quotient is written, and write 0 after the decimal point. So we can now assume the dividend as 10. So let's start dividing the numbers. 10 divided by 4 is 2. And let's multiply 2 and 4, and the product will be 8. And let's subtract 10 to 8, and that is 2. And let's write another 0 in the dividend and bring down, and it will give us 20, and divide 20 to 4, and that is 5. Then multiply 5 to 4, so the product will be 20. And subtract 20 to another 20, and it will leave. So the fraction 1/4 is equal to 25 hundredths in decimal form. And when we divide the numerator 1 by the denominator 4, it will give us 25 hundredths as our decimal quotient. And for Mrs. Reyes, wherein she buys 1/3 kilogram of chicken, so same with this fraction, 1 as our dividend will be written inside the division symbol, and 3 as our divisor will be written outside the division symbol. And then let's divide the given numbers using the long division. So 1 divided by 3 is 0. Since the dividend is smaller than the divisor, so we will put a decimal point after 1 and then write it above, and then write another 0. So we can now assume that the dividend is 10. And then 10 divided by 3, the answer is 3. And then multiply 3 in the quotient to 3 in the divisor, and the answer is 9. And let's subtract 10 to 9. The difference is 1. And then let's add another 0 in the dividend and then bring it down. So it will give us 10. And then divide 10 to 3 in the divisor. So 10 divided by 3, the quotient is 3. And then let's multiply 3 in the quotient to 3 in the divisor. And the product will be 9. And then subtract 10 minus 9, the difference is 1. Since we still have a remainder 1, so we will add or we will write another 0 in the dividend and then bring down. So that will give us 10. And then divide it again to 3, and the quotient is still 3. And then multiply 3 in the quotient to 3 in the divisor, and that is again 9. And when we subtract 10 to 9, the difference is again 1. Can you observe a pattern in the solution and in the quotient? Very good. If we continue writing 0 in the dividend, the quotient is always 3. And the digit is always repeated. Or the digit 3 is always repeated. So we will just leave it as 0.333 and write 3 dots, or called as ellipsis, which means it continues infinitely repeating the pattern. Or we can write it as 0.3 with the bar above the digits that is being repeated. So 1/3 is equal to 0.333 with an ellipsis, or 0.3 with a bar above 3. Which means both Mrs. Santos and Mrs. Reyes got the right weight of meat. So as you can see in the given problem, we solve for the 2 different decimal quotients. And these 2 decimal quotients can be classified into 2. These are terminating decimals and repeating non-terminating decimals. So as for the example of these 2 types of decimal quotients, 25 hundredths is an example of terminating decimal, while for repeating non-terminating decimal, the example for this is 0.333 with an ellipsis, or 0.3 with a bar above 3. Thus, terminating decimals means decimal numbers with finite number of digits after the decimal point. So finite means having limited or countable number of digits. And terminating decimals result when the division terminates or comes to an end with a 0 remainder. So going back to the problem as our example, when we divide 1 to 4, it will give us a quotient of 25 hundredths, and it also has a 0 remainder, wherein the quotient has finite numbers of digits after the decimal point. Another example of terminating decimal is when we divide 7 by 2. So let's start dividing the numbers. So 7 divided by 2 is 3. And then let's multiply 3 and 2. So the product will be 6. And subtract 6 from 7. And the difference will be 1. Since we still have a remainder, so we will write decimal point and also above it, and also 0 after the decimal point, and then bring down, and it will give us 10. And let's divide 10 to 2. So 10 divided by 2 is 5. And let's multiply 5 and 2. So the product will be 10. And subtract 10 from another 10, and it will give us a 0 remainder. So as you can see, the division terminates or comes to an end, and we also have a zero remainder. So this is an example of terminating decimal. However, not all numbers, when divided, can obtain a quotient with zero remainder. And these numbers, when divided, can have a repeated decimal quotient. And this is called as repeating non-terminating decimals, wherein it has infinitely repeated digits after the decimal point. And it results when the division never ends, so we will put a bar, or we will place a bar above the repeated digits, or write an ellipsis after the digits. So like the given in the problem, when we divide 1 to 3, there is a repeated pattern in the solution, and we cannot obtain 0 as our remainder. So and as we write another 0 in the dividend, the quotient we get does not end. And the digits in the quotient are continuously repeated. So we write 3 dots, or code as an ellipsis, in the quotient, or we write the decimal as, or we put a bar above the repeated digit. Another example is when we divide 2 by 11. So 2 divided by 11 is 0. Since the 2 in the dividend is smaller than the divisor, so we will put a decimal point after 2 and also above it, and we will write 0 after the decimal point. So we can now assume the dividend as 20. And then let's start dividing the numbers. 20 divided by 11, the answer is 1. And then let's multiply 1 to 11. That is still 11. And let's subtract 11 from 20. So the difference is 9. And then let's add another 0 in the dividend and then bring down. So that will give us 90. And divide 90 by 11. So the answer is 8. And multiply 8 to 11. And the product will be 88. And subtract 88 from 90. So the difference will be 2. Since we still have a remainder, so we will write another 0 in the dividend and then bring down, and it will give us 20. And then divide again the number to our divisor. So 20 divided by 11 is 1. And multiply the quotient to the divisor. So 11 times 1 is 11. And subtract. So 20 minus 11 is 9. Okay. So, can you observe a pattern here in our solution? Okay, very good. So, as we write 0 in the dividend, our quotient will always be, our quotient will always be 1 or 8. So, we will just leave it here. So, we will write now our quotient as 0.1818, or with an ellipsis or 3 dots, or we will write it as 0.18 with the bar above 18, since 1 and 8 are the 2 digits that are being repeated. So when we divide the numbers, as you can see, there are digits that are repeated no matter how many digits or no matter how many zeros we add. And we cannot get a 0 remainder. Okay, so let's try to identify the decimal quotients if it is a terminating decimal or repeating non-terminating decimal. Here in our first activity entitled, Will You Do the Math? So here's the direction. Spin the wheel and answer the division problem that is being selected above the red arrow and identify what type of decimal is the quotient. Okay, let's start. So here's our spin wheel And let's spin the wheel. Okay, so our first division problem is 6 divided by 4. So let's divide 6 to 4. So 6 divided by 4. So 6 is 1. And then 1 times 4 is 4. And then 6 minus 4 is 2. And then let's write let's write decimal point after 6. And also 0. And then let's bring it down. So 20 divided by 4 is 5. And then let's multiply 5 to 4. That is 20. And then let's subtract 20 to 20. So the difference will be 0. So now, what type of decimal is this? Is this a terminating decimal or repeating non-terminating decimal? You can write it on the comment box. Okay, very good. This is an example of terminating decimal. Another spin. Okay, so the second division problem is 5 divided by 11. So what do you think will be the quotient when we divide 5 to 11? Is it a terminating decimal or repeating non-terminating decimal? Okay, let's check. So if we divide 5 by 11, so 5 divided by 11, since 5 is smaller than 11, so we will write a decimal point after 5 and also a 0 after the decimal point. So we can now assume our dividend as 50. And let's divide the numbers. 50 divided by 11, that is 4. And then 4 times 11, the answer is 44. And then let's subtract 50 and 44. So the difference is 6. And then write another 0 in the dividend and then bring down. So that will be 60. And then divide 60 to 11. So the quotient is 5. And let's multiply 5 to 11. So the product will be 55. And let's subtract 60 to 55. So the difference will be 5. Since we still have a remainder of 5. So let's add another 0 in the dividend. And then bring down. And then divide 50 to 11. So that will be 4. And 4 times 11 is 44. And when we subtract the numbers, the answer is 6. Okay, can you observe a pattern in our solution? So what do you think is the type of decimal we have in our quotient? Okay, this is an example of a repeating non-terminating decimal because the division never ends and the digits in the quotient are repeated. So we will write it as 0.4545 with 3 dots or code as ellipsis, or we can write it as 0.45 with a bar above 4 and 5. Okay, another spin. Okay, so the third division problem is 7 divided by 9. Okay, let's try. So when we divide 7 by 9, so 7 divided by 9, 7 is smaller than 9. So we will add a decimal point after 7 and we will write a 0 after the decimal point. So we can now assume our dividend as 70. And let's start dividing the numbers. 70 divided by 9 is 7. And then write 0 above 7 and also a decimal point. And then let's multiply the numbers. 7 times 9 is 63. And let's subtract 70 minus 63 is 7. And let's write another 0 in the dividend and then bring down. So that will be 70. 70 divided by 9 is 7. And then let's multiply 7 to 9. So 7 times 9 is 63. And let's subtract 70 to 63. 70 minus 63 is 7. Since we still have a remainder 7, so let's write another 0 in the dividend and then bring down. So that will become 70. 70 divided by 9 is still 7. And let's multiply 7 to 9. And we still get, and again, we get 63. And let's subtract 70 to 63. Okay. So as you can see, as we write 0 in the dividend, we get a quotient of 7. So what type of decimal it is? We have here in our quotient. Okay, so this is an example of a repeating non-terminating decimal. We can also write it as 0.777 with 3 dots or code as an ellipsis, or 0.7 with a bar above 7. Another spin. Okay, so we have here 33 divided by 4. So let's divide. 33 divided by 4 is 8. And then 8 times 4 is 32. And then subtract 32 from 33. So the difference is 1. And then write a decimal point and a 0 after 33. And then bring down 0. So that will be 10. And then divide 10 by 4. And that is 2. And then multiply 2 and 4. That is 8. And subtract 10 to 8. So the difference is 2. And then write another 0 in the dividend and then bring down. So that will give us 20. And then 20 divided by 4 is 5. And then let's multiply 5 and 4. So the difference will be, the product will be 20. And when we subtract 20 to another 20, the difference is 0. Since we get a 0 remainder, what type of decimal it is? Okay, so that is an example of a terminating decimal. For the last spin, okay, we have here 4 divided by 66. So let's divide the numbers. 4 will be our dividend and 66 will be our divisor. Since our dividend is smaller than our divisor, so we will add a decimal point and a 0 after 4. So that will be, or 2 zeros after 4. So that will be 400, or our dividend will be 400. Or we can now assume this as 400. So let's divide the numbers. 400 divided by 66. Or how many 66 are there in 400? So we have 6. And then let's multiply 6 to 66. And the product will be 396. And let's subtract 400 and 396. So the difference will be 4. Since we still have a remainder 4, so let's add another 0 in the dividend. And then bring down. So the number will be 40. And divide 40 by 66. And the answer is 0. Since we cannot get 66 from 40. Or there's no 66 in 40. And let's multiply 66 to 0. So the answer is 0. And then let's subtract 40 to 0. And the answer is 40. And then let's add another 0. Or let's write another 0 in the dividend and then bring down. So the number will be 400. And then 400 divided by 66 is 6. And then divide 66 to 6. So the product will be 396. And when we subtract the two numbers, the difference is 4. Okay. So as you can see, 0, the digits after the decimal point are 0 and 6. And then another 0 and 6. So the digits 0 and 6 are being repeated. And we still have here a remainder 4. So what type of decimal we have here in our fifth example? Okay, so this is an example of repeating non-terminating decimal. We can also write our dividend, our quotient as 0.06 with a bar above 0 and 6, which is the two digits are being repeated. Okay, so you all do well. Great job, grade 6 pupils. Since you already know the difference between terminating decimal and repeating non-terminating decimal, let us proceed now in word problems involving division of decimals. But let us recall first the steps in solving word problems. So the first step is understand the problem, know what is being asked, and identify the given facts. And for the second step, we need to devise a plan by thinking of a strategy on how to solve a problem. And for the third step is to carry out the plan by solving the problem. And for the last step is we need to look back or check if our answer is correct. So let's use the steps to solve our first example. So here is the first example. Sandy gives 1,200 kilograms of grains a day to feed a goat. How long will 3 kilograms of grains last to feed the goat? So for the first step, we have here, we're looking for the number of days will 3 kilograms of grains last to feed the goat. And for the given, what do you think is the given? Okay, so we have here 1,200 kilograms of grains a day and 3 kilograms of grains. And for the second step is we need to devise a plan. So in this problem, we will divide 3 by 1,200. So our number sentence will be n is equal to 3 divided by 1,200, wherein n is equal to the number of days will 3 kilograms of grain last to feed the goat. And then let's carry out the plan using the number sentence, wherein n is equal to 3 divided by 1,200. And then let's divide 3 by 1,200. Okay, so as you can see, 3 will be our dividend. So it will be written inside the division symbol, and 1,200 will be our divisor. So it will be written outside the division symbol. And also, our divisor has a decimal point or in a decimal form. So to solve this problem or to solve this division problem, we will move the decimal point from left to right until the divisor become a whole number. And if we move the decimal point from left to right in the divisor, we will also change the dividend by moving the decimal point two places also from left to right. So our given will be 300 divided by 12. Okay, so let's start dividing the numbers. 30 divided by 12 is 2. And then let's multiply 2 and 12 So that is 24. And then subtract 24 from 30. So the difference is 6. And then bring down 0. And then divide 60 to 12. So the quotient is 5. And multiply 5 to 12. And the product will be 60. And if we subtract 60 to another 60, it will leave us a no remainder. So n is equal to 25. Okay, let's check our answer. Since division is the opposite operation of multiplication, so we will multiply our quotient 25 to our original divisor, which is 12 hundredths. So 12 hundredths times 25. So 5 times 2, that is 10. Write down 0, carry 1. 5 times 1 is 5, plus 1, that is 6. And then 5 times 0 is 0. And then 2 times 2 is 4. 2 times 1 is 1. 2. And 2 times 0 is 0. And then let's add our partial product. So bring down 0. And then 6 plus 4 is 10. So write down 0, carry 1. 1 plus 0 plus 2, that is 3. And then bring down 0. And as you can see, we have here decimal point or decimal places in our factors, and that is a total of 2 decimal places. So we will move our decimal point in the product 2 places from right to left. So the answer will be 3. Okay, so 3 in our, so 3 as our product is also the same in the dividend. Okay, so the 14 kilograms of grains will last up to 25 days to feed the goat. Okay, second example. A bamboo pole that is 3 and 900 meters long is equally divided into 3 pieces. How long each is piece? Again, the first step is to understand the problem and identify what is being asked in the problem. So what is being asked in the problem? Okay, so we're looking for the length of each piece of bamboo. And for the given, what are the given? Okay, so we have here a bamboo pole that is 3 and 900 meters long, which is equally divided into 3 pieces. Okay, and for our second step, which is devise a plan, so we will solve this problem using an illustration. So we have here a rectangle, and this rectangle represents the bamboo pole that has a length of 3 and 900 meters long, which is equally divided or equally cut into 3 pieces. So we have here our first piece, second piece, and third piece. Since the bamboo pole is divided into 3, so we will divide 3 and 900 meters by 3. So the quotient will be 1 and 300 meters. So each piece has a length of 1 and 300 meters. So to check our answer if that is correct, so let's multiply 1 and 300 meters by 3. And we get the same answer, which is 3 and 900 meters, which is also equal to the length of the bamboo pole, or the original length of the bamboo pole. So each piece has the length of 1 and 300 meters long. Okay, you remember, class, a terminating or decimal quotients can be classified into 2. So the first one is, we called it as a terminating decimal, which results when the division terminates or comes to an end with a zero remainder. And another type is a repeating non-terminating decimal, which results when the division never ends. So we will just place a bar above the repeated digits, or we will just write an ellipsis after the digits. So for clarification and other concerns, you may type it in the comment box, and later on we will discuss it. Okay, so for our first question from San Miguel Heights Elementary School, so this was her question. Why do we need to name the repeating non-terminating decimal as it is? Why not naming it as non-terminating decimal only? Okay, very good question. It is because non-terminating decimals can be classified into two. Those are repeating non-terminating decimal, so that is the first classification, and the second is non-repeating non-terminating decimal. For the repeating non-terminating decimal, we have already discussed it earlier, while for non-repeating non-terminating decimal, one of the example of this is the value of 5, wherein the digits after the decimal point does not end, and at the same time, it has no group of digits repeated. Okay, since we don't have much time, so thank you grade 6 pupils for actively participating to our discussion. Hope you all do well. See you next time. Goodbye.